Okay, lesson 70, probability in designated order. If you don't like algebra, this is a nice little break for you. This lesson is rather long, but it's pretty simple. So let's get started. The study of probability is based on the study of outcomes that have an equal chance of occurring. Like, for example, if you're flipping a coin, you have an equal chance of getting a head or getting a tail. So that's the kind of outcome that have an equal chance of occurring. We define probability of a particular event as the number of outcomes that satisfy the requirements divided by the total number of outcomes in the sample space. So all this probably sounds foreign to you right now. I'll try to make it come down to your level in a minute. So if you're trying to figure out like the probability that you're going to flip a heads when you flip a coin, the probability of flipping a head, so you put the P with an H in it, says the probability of heads is the number of outcomes that satisfies that requirement. So how many, if you have flipping a head, you only have two choices, so the number of outcomes that satisfy that requirement would be 1, and the total number of outcomes in the sample space. Well, your coin only has a head and a tail, so there's two possible outcomes. So the probability of flipping a head is 1 out of 2. So your probability is 1/2, or you could say 50%. The probability of any event is a number between 0 and 1. So you're not going to get 3. The probability of flipping a head is 3. It's always going to be between 0 and 1 if no outcomes satisfy the requirement. Like, what's the probability of flipping a coin and getting 3? Well, there's no 3 in a coin, so the probability would be 0 out of 2. And 1 inclusive. If no outcomes satisfy the requirement, the probability is 0, and every outcome satisfies the requirement, the probability is 1. If you have a coin that has 2 heads on it, the number of outcomes that satisfy the requirement would be 2 out of 2, so it would be 1. So probability is always going to be between 0 and 1. Most likely it's going to be a fraction. Let's start out with our coin problem. A fair coin is tossed 3 times and comes up heads every time. What is the probability that the next toss will come up heads? Now our temptation is to think, wow, it's coming up heads more, so maybe it'll come up heads again. Tossing a coin is an independent event. Once you toss it, you're starting all over with the same probability. So a coin is tossed 3 times and comes up head. What's the probability that the next toss it'll come up heads? It's the same thing. It's going to be the probability of coming up heads. Even if it's been heads for the last 10 times, it's an independent event. So it's 1, there's only 1 head possibility out of the total number of outcomes is 2. So your answer is still 1/2 for each time. Let's try another one. See, I told you these were pretty easy. 6 green marbles, so we have 6 green marbles and 8 red marbles are placed in an urn. For some reason they always use urns. I would probably use a bag or something, you know, a sack, an urn, I don't know where they get that. 1 marble is drawn and then dropped back in the urn. Then a second marble is drawn and dropped back into the urn. Both marbles were red. If another marble is drawn, what is the probability that it will be red? Now they're trying to throw us. They're making us feel like it's going to be red again. But these are independent events. Every time you're starting over. All the marbles are in the bag, and it's just random what you're going to pick. So remember our formula that we had here. It's up here. Particular event is the number of outcomes that satisfy the requirement over the total number of outcomes in the sample space. Alright, so what is the probability of being red? Well, that's what we're looking for, so it's going to be 8 is on the top, out of the total number in the sample space. So that's out of the total number of marbles in the bag. So it's going to be 14. So the probability, we're always going to reduce these. So the probability of drawing a red marble is 4 out of 7. So if you draw 7 marbles, there's a good chance you'll get 4 red marbles, because there's more red marbles than green marbles. Easy stuff. Okay, let's go on to the die. A single die is rolled 3 times. The first time they got a 1. In the book they have it written nice and cute like this. The second one they had a 4. And the third one they rolled was a 3. What is the probability that the next roll will produce a number greater than 2? Okay, this is getting a little bit more complicated. First of all, these are independent events. Every time you roll a die, it doesn't depend on what happened before. It's not going to go, if you roll 1, the 1's not going to disappear from the die, it's still going to be there. So we want to figure out what's the probability that the next roll will produce a number greater than 2. So when you roll a die, you can get 1, 2, 3, 4, 5, or 6. So the total sample space is going to be 6. There's 6 things that could come up. How many are we looking for? We're looking for numbers greater than 2. So it would only be these 4 are greater than 2. So 4 out of 6 will give us a 2/3 of a chance that we're going to roll a number greater than 2. Let's go on to something a little bit more complicated. 2 dice. Here we go. 2 dice are rolled. What is the probability that the sum of the numbers rolled is a 7? So it's the sum of the numbers rolled is a 7. So here we go. This is all our possible outcomes, this chart. If you roll 1 and 1, you get 2. These are all the things that could possibly be. So our sample space with 2 die, if we figure this out, it would be 6 times 6. So the probability of getting a 7, the sample space is 36. Of getting a 7, we would count up all the 7s. 1, 2, 3, 4, 5, 6. So it's 6 out of 36. And that would give us a 1/6 probability that we would roll a 7. This chart is really helpful and it's in your book. What's the probability that we would roll a number greater than 8? Well, let's see. Roll a number, a sum of a number greater than 8. So you can write that like that. Well, our sample space is still the same. We have 36 possibilities. Greater than 8. Well, we just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it'd be 9 and above. So there's 10 possibilities out of 36. We can reduce this, divide them both by 2, and we get 5 out of 18. So every 5 times out of your 18 rolls, the probability is good of getting an 8. Okay, that's it for the first part of our lesson, which is probability. Now we're going to talk about designated order. We're just going to get a little bit more specific here. The probability of future outcomes of independent events happening in a designated order is the product of the probabilities of the individual outcomes. So what that means is, what's the probability of rolling a heads and then rolling a tails? Well, these are independent, remember, it doesn't matter. It's not like we're pulling a marble out of a bag and not putting it back in. When we roll a coin, the heads and tails are both still there. So you figure out the probability of rolling a head, of flipping a head. We figure out the probability of flipping a tail, and we multiply it together, and that gives us the probability of rolling a head, then a tail. And you can see this in this little diagram. First toss, we would get a heads or a tail, and then after that, we would get a heads or a tail. So there's 4 possible. It's 1 out of 4 that we would get a head, then a tail. So let's try one of these problems. A fair coin is tossed 4 times. What is the probability that the first time it comes up head and the last 2 times it comes up tail? Well, we know the probability of a head times the probability of a head times the probability of a tail times the probability of a tail. And we did enough of these coin problems that we know the probability to get a head is a half. 1 out of 2, another head is 1 out of 2, tail is still 1 out of 2, and another tail is 1 out of 2. So the probability would be 1 out of 16 that we would roll a head, then a head, then a tail, then a tail. So these are just designated order. So it's the probability of the possible outcomes that satisfy the requirements divided by the total possible outcomes. Okay, last one. The spinner shown is spun twice. What is the probability the spinner stops on 4 and then on 3? Well, if the spinner stops on 4, we would figure out the probability of 4 times the probability of 3. Well, the probability of 4 is there's only 1 4, so that goes on the top out of 4 possible outcomes. The 3, there's only 1 3, so 1 3 out of 4 possible outcomes. And again, we get 1/16. Here's the probability of spinning a 4 and then a 3. 1 out of every 16 times. That wasn't too bad. Alright, that's it for lesson 70.